So nodes. Nodes are the most important aspect of a cage. So that's where all of your tube junction points are. And you want those reinforced from multiple areas. So if everything lines up, so say, I have a tube coming from here to up to the top, which I will, and then the same with the A-pillar, those forces are gonna, if you get in an accident from the A-pillar, it'll transfer that force into that, and because the B-pillar doesn't have any strength to hold it this way, but this tube coming here does. So you want all those junction points aligned, because if they're offset, it'll just bend the tube in between, and that's not safe. So, you want to get as much structural rigidity out of this and, occupant safety. So you're trying to build just kind of a big ball to protect yourself. But that's where most errors I've seen in cage work is node junctions, because you don't want the cage to give. It's not designed to be a crumple zone. This isn't like a traditional car. Once you're in with harnesses and a Hans device and all that stuff, your crumple zones are out. Like outside of the cage, that's fine, but you want the occupant area to be, very strong. So, trying to prep to do cage things. So I took the glass out in the front because I'm gonna want to do gussets up to here. I pulled the dash out to kind of see what's going on. I need to do a bar behind the dash between the two A-pillar bars, and I need to find out, I'm gonna have to kind of cut this corner a little bit and get the leg of that A-pillar down bar far enough forward. On top of that, I've prepped some of these little areas in here. And then you need to do a minimum 1/8" plate for all your cage landing pads. So the tube's gonna land somewhere over here. So I've made the plates for both these sides. It's also gonna tie into the back of the B-pillar, but we're gonna deal with that later. This will be the rear down bar location from the B-pillar hoop. But before I can start doing any real cage work other than prepping these locations, I need to get the seats mounted, understand where that's gonna be, and then I can start figuring out my cage stuff from there. So I played with a bunch of cardboard boxes and kind of chunks of foam, shimming the seat around, trying to play make-believe in the car, see what felt nice. So these cars are kind of goofy. The A-pillar slopes back a bunch. So this top portion of the windshield feels really close in the car. So I ended up having to recline it a little bit so that I feel more centered in the car. I did some measurements once I had my seat held up by chunks of foam and whatnot, and went to cardboard template mode, and then made the steel version. So I made a set for each side, and I have another set mounted on the other seat. So those will be my seat mounts to the floor. These are to the stock mounting locations, but I was playing with that just now. The stock mounting locations are little M6 bolts, which I don't trust. So I'm gonna box in those areas and weld in a captive nut so that it's an M8 location for these brackets to the floor. Because it's an M8 from these side brackets to the seat, and then everything will be nice, 10.9 hardware. It's very subtle, but there's a small bend in the middle here. So I'm trying to keep the cage as tight to the outside of the car as possible, just to give myself the most space and kind of keep all the tube away from me. So, and I think a nice tight fitting cage is the best way to go. It looks the best, it's the highest quality stuff. So I like trying to practice and doing that. So I have like a little, it was a 4-degree bend in the center just to get the extra 3/4 of an inch up so that it met the contour of the roof. Which is, that's like the best part about using the software, is I can measure all that and then it'll give me the instructions to give it just a little bit of a bend so that I can kind of keep everything nice and tight to the outside of the car. So with this program, this is BendTech Pro. I've been using it for a little bit just because tube's expensive. It's a long gap usually between me doing a couple cages. While I really like cage work, I usually forget a couple things about the bender, some of the radiuses, kind of my clearance in certain areas. So the software is really handy. You can check and measure stuff before you like commit to bending the part. So this, for what I did here, is I can give it kind of dimensions of, I came up towards the ceiling 11 inches, to the right 1 inch for this first bend, and I keep going through sort of a coordinate system that way until I get a part, and then I can verify it and kind of just check some measurements from like outside of bend to outside of bend, and then make sure that's going to work with the car. It saves me, you know, especially, usually you have to start with the B-pillar hoop, which is your longest section of tube, thereby kind of the most expensive and riskiest one to bend first, especially if you haven't bent tube in a little while. So verifying all that and making sure it's going to fit is useful. So that's what I started with, kind of took my time with that. And then it gives you instructions for your bender once you program, well, a bunch of different benders are already loaded, mine was in here. So I know that I had to mark, you know, a certain length from the end of the tube for where the die goes, and then the degrees of each bend. So then I can kind of, it gives me basic instructions. If you're doing other compound bends, this is all one plane, but a non-planar bend will be the A-pillar bar. So it'll actually give me like a twist in degrees between each bend when I set it up in the bender. So that way I can kind of contour along, you know, because the top of the A-pillar is further in than the bottom of the A-pillar. So I have to jog out and down. So very useful, very helpful, worth the money for this and what I would have wasted in tube otherwise. You know, the main aspect of a roll cage is to keep you safe and enhance the structure of the vehicle in the case of an incident where you crash. So, the name of the game is essentially triangulation. So, that's why you have to put in all these diagonals or X's in various parts of the cage, so that if I take a hit here, it'll transfer the load over to here and kind of spread it out throughout the entire chassis instead of just one corner that would crumple and, you know, could injure me. So that's why they're very strict about all of the different cross members and X's you need to have in the chassis. I mean, you could do a couple different roof configurations. So I could have done a V, and if you do that, then you have to do a V for this one as well. It's basically all the nodes we talked about earlier. So there's a bunch of different options, but they all have to be used together in a way that makes sense. The X is the more structurally sound way to go, which is why I'm doing it, and I think it looks better. Go to 57. I overshot 50. Oh, hey, taking it. Like if you consider a bend on a plane, so if you were to put a flat piece across this, that would be the plane the bend is on. Not all bends can be planar when you're trying to go around stuff. Like I'm trying to go from the bottom of the B pillar to the bottom of the A pillar while coming out to the door sill. So I have to come down, this whole piece will be out a little ways, and then it has to come back in towards the A pillar. So that means all these bends are on different planes. And that's what I'm changing with that degree angle finder doohickey. Excellent term. So, you know, once you do your first bend, you set that plane and zero it, and then you can change how many degrees it is to the next plane.
Better explanation.
Better explanation. Well in the background. So I have to notch it till it fits there. Then I have to notch it so it fits here. Is the next kind of hard part, because not only can I ruin it there, I can now ruin it over here. I figured out I can come out towards the door a little more. So with the door shut, the door sill I was going to is further away than I thought. I have more space. So I can just don't touch the knees now. Okay, kind of. Next thing I need to do is start locking up this end so that it's getting close. I did the sill bars, got those knocked out. Then, now that I am confident in my harness bar placement, I'm going to do that on this side as well. And then I can do the X in, you know, the actual door bars, which are going to be an X in this case, and it's going to be a bent lower and then a bent upper. And then where they intersect, you have to do a bunch of gussets. So I wanted all that to line up with the nodes for the harness bar and the dash bar. That's why those had to go in first, and it also has to land at this node back here where the sill bar is. So kind of had to figure out a bunch of things before I could get those done.
As a whole, how do you think the roll cage is going?
It's going. It's going. A little slower than I wanted it to go. But, yeah, getting there. There's still a ton to do. So while I have most of the tubes figured out, there's still going to be the whole... I have to still do all the gussets. So I made the sill bars so that they'll be able to be welded right to the door sill of the car. So that'll be nice. That'll be nice and strong. I have to do the plates for the A-pillar here. I'm going to see if I can do a plate for the B-pillar. Not entirely sure. Might look a little silly. Just because this B-pillar is kind of far forward. But also, the top of the harness bar, I can weld right to the roof. So, I gotta clean up all those areas. I'm actually gonna cut the roof off the car to pull the cage out to finish weld it, and then we can put it back in.